Okay, hello there, I'm back again, and as I told you in the last video, I'm back with a few problems based on limit comparison test. Anyway, in the last video we did some questions, but these are some extra important questions, or let's say unless and until we do in a special manner, we will not be able to solve it. We won't be able to solve it that easily the way which we did in the last video. So, as always, I'm going to ask, do you have a piece of paper with you? If not, pause the video, make sure you have a piece of paper and pen. So, shall we start? Okay, so I wanted to note the first question. Test for convergence. Yeah, it's right in front of you. So please write the first question. Test for convergence. Yeah, sigma root under n to the power 4 minus 1 minus n square. Okay, so what's the first thing to do when you have a question in convergence or divergence? Yeah, the first thing to do is you have to give it a name. So let's do those things. Yeah, so let's give it a name. So let's assume the given series is sigma un. I hope you're noting and you're trying to work out the problem along with me. So I'll explain step by step very slowly. Okay, so the next thing is you extract un from our series. Okay, now let's discuss about the problem. In the last questions, you can pause the video and check the last video if you are not sure what we did in the last video. Anyway, the problems which we did in the last videos had negative degree. So what I'm trying to convince you here is, when you calculate the degree of un, each and every time we had a negative answer. And since this degree was negative, we were able to construct Vn and we were able to change Vn into the P series. So that's why I told you earlier, unless and until the degree is negative, our limit comparison test won't work, or we won't be able to use limit comparison test that easily. Okay, so what is the degree of root to the power n power 4 minus 1 minus n square? As you notice, the highest power of n is 4, but it comes inside a square root, so the degree of un is 2. Anyway, 2 is positive, so we won't be able to proceed. So I go for one simple trick, that is multiplying numerator and denominator by the conjugate. Okay, now someone tell me what is a minus b into a plus b. I'm sure all of you know this identity because you had been using this identity since your high school. Okay, so that gives me a square minus b square. Now take a good look at the numerator. Can you see our a minus b and a plus b? So you'll be able to simplify the numerator and you're going to get something like this. Because when you square, the square root will be gone, and when you square n square, it will become n to the power 4. So go ahead, cancel this. I hope I'm not going fast, and I hope you reach this step. So let's move ahead. And if you have any trouble with the past steps, you can just look at the left side of the screen. You don't have to go back and check the initial part of the video. So you can just check the left side of the screen. Okay, finally we have our un. Look at this numerator. In the numerator, I'm not able to see n. And if there is no n, then what's the degree or what's the power? Yeah, because n to the power 0 is equal to 1. And the denominator, yeah, I can see n power 4, but as I told you before, it comes inside a square root. So the highest power the denominator can give me is just 2. And how do you find the degree of a quotient? Yeah, degree of numerator minus degree of denominator, and that gives me minus 2. And finally, I'm really happy because the degree is negative. And the degree is negative means we will be able to construct Vn, and moreover, sigma Vn will be a P series. And I know everything about the P series. I know when the P series will converge and when the P series will diverge. So I'll repeat for the last time. Now we have the degree negative, so you can go ahead, you can construct Vn as before and apply limit comparison test. So do you still remember how we construct Vn? Yeah, you're right, n to the power degree. And what's the degree here? Minus 2. See? And what is n power minus 2? Yeah, 1 by n square. So I'm going to take sigma on both sides, and there goes our P series. What's the value of P? 2. And a P series will converge if the P value is more than 1. And 2 of course is bigger than 1. So sigma Vn is convergent. And as always, don't forget, call it equation number 1. So what's the last thing to do? There's one more thing. What's the name of the test? Limit comparison test. And as the name suggests, we're going to go for the limit. Okay. So now we will take limit n tends to infinity un by Vn. We have un on the left side of the screen, and we have Vn somewhere here. So go ahead, substitute, and keep in mind one thing. Okay, there goes our substitution, un and our Vn. Okay, now I hope you remember what we did in the last video. Whenever we have a limit which is related to infinity or which tends to infinity, we try to create 1 by n, or maybe 1 by powers of n, because we know 1 by powers of n will tend to 0 if the powers are positive. Okay, so what can we do with this n power 4 minus 1? Yeah, I'm going to take that n power 4 outside the bracket, so I'll get something like this. And let's move ahead to the next step. So this is what I did. And what's the value of root under a into b? That will be root a times root b. So can you see here, root under a into b? Exactly. So it's going to split, and we are going to get something like this. Now we have a common factor in the denominator, which will get cancelled outside in the next step. So I hope all of you have reached this step. So let's move ahead. Yeah, okay. So there goes, yeah, here it comes outside. So let's cancel. And now tell me, what will happen to this 1 by n power 4? Of course it becomes 0. So root under 1, that is 1. So the denominator will be, yeah, so you're going to get this. going to get this. So I have the step here, and I have one more step. So I hope you have a very clear idea about the limit comparison test. Now the conclusion depends on equation 1 and equation 2. So tell me, how do you conclude limit comparison test? So we have two positive termed series, sigma un and sigma vn. Sigma un is our question, and sigma vn is the series which we generated using the degree of un. And by equation 1, this is convergent. And look above, the limit n tends to infinity un by vn is not equal to 0 and is finite. That means both the series will behave alike. What does this imply? What does equation 1 and 2 imply? Both the series will behave alike. Now, by 1, sigma vn is convergent, and that implies our question, sigma un, our series, will also converge. I hope you're enjoying the method. Okay, now let's go for the worst case scenario. Yet another question, which is a very special question. So please note the question. Test for convergence. Yeah, this makes things really bad. It's cube root. Don't read 3 into root. Read this as cube root. Okay, so we have cube root of n cube plus 1 minus n. Okay, I've seen many different methods to solve this problem, but I always feel the binomial series method is the best, because let it be any power, let's cube root, 4th root, 5th root, etc. The binomial series method works really good. So let's move ahead. So tell me, what's the first thing you will do when you're asked to test for convergence or divergence? Yeah, first thing to do is to give it a name. So we have a name, sigma un. So let sigma un be the given series, and I hope you know that cube root of x is x to the power 1 by 3. So are you okay till this step? Yeah. Now I have to explain something very important. The binomial series is 1 plus x the whole power n, and the formula goes like 1 plus n times x plus n into n minus 1 by 2 factorial x square plus etc. etc. And the main point is, this formula works good if modulus of x is maintained less than 1. And that's why, my friends, we make it 1 plus 1 by format, because our n in a series, n starts from 1, 2, 3, etc. because first term, n means the subscript of un. So the first term, the second term, the third term, etc., etc., so that we make sure the modulus of n is kept less than 1. Okay, so let's move ahead. I hope you're okay with ab the whole power n being a to the power n, b to the power n, and n cube the whole power 1 by 3 gives you n. So are you okay with this step? Okay, now let's go for the most important step in this formula. Now let's go for the most important step in this problem, that is the expansion. So we have the expansion on the left side bottom of the screen, and on the right side I just applied the formula. And remember, we have 1 plus, okay, this will act as x in our formula. So 1 plus, it's not a big deal, you're just applying the formula. And can you see the numbers like 1 by 3 into 1 by 3 minus 1, 1 by 3, 1 by 3 minus 1, 1 by 3 minus 2, etc. Okay, if you really want to simplify, you can simplify, but I'm not going to simplify the numerator or the number part. You can find 2 factorial, simplify, make it look small, etc. But I'm not going to waste my time simplifying this part. But it's completely up to you. If you want to simplify, but in this video I'm not planning to simplify. Okay, so let's move ahead. Yeah, so we have the expansion here, and then what I did is, okay, tell me what is a into b plus c plus d plus, okay, that's it. You just find a into b plus a into c plus a into d, or you apply the distributive property. You distribute a inside the brackets. So that's exactly what happened here. N into 1, and then n went inside, okay, and the power became 1 by n square. And then n went to this term, and look at the power became n power 5. And then n went inside this term, but I'm a little bit lazy, so I didn't write that. So there goes our n and minus n, and this is the remaining part. Okay, now I'll ask you one question. Can you make a guess? What will be our degree? What's the degree of un? Degree means the highest possible power of the variable or the letter used for the polynomial. Here we are using n. So what's the degree? What's the highest power? Yeah, I think you're able to guess. The degree is minus 2, because look at this, the powers of n keeps on decreasing. It's a negative, so the power keeps on decreasing. So the degree of un is minus 2. And now I don't have to explain much, because I'm sure you know what to do next, and then what to do, and finally you got it convergent. So tell me, how did you get it convergent? Can you see the p series with p being equal to 2? And that means p is bigger than 1, and of course sigma vn is convergent. Now guys, we have one more step left, and that is the limit. So we're going for the limit, and it goes like this, and that's it. Now you can just apply the limit, and as I told you before, when n becomes big, really big, 1 by powers of n, for example, this will be 0, 1 by n to the power 6 will be 0, so all these terms are going to disappear. Okay, so once more we cancel this, and then we apply the limit. All these things are going to vanish, so we end up with the limit 1 by 3. So now tell me, what is the conclusion? We have sigma un, that is our question, and then we have another thing, sigma vn, and that is convergent by equation 1. And then we found that limit un by vn is not equal to 0 and finite. So according to limit comparison test, both the series will behave alike, both the series will behave the same. But we already know sigma vn is convergent. That means sigma un is also going to converge. So I hope you're okay with this. Anyway, this will be the last video related to limit comparison test, or the numericals related to limit comparison test. In the next video, we'll be discussing about D'Alembert's ratio test, and we'll be doing problems based on the ratio test. Anyway, if you have any doubts regarding limit comparison test, you're free to mail me. You can use this email ID, or if you want to make any videos related to any particular topic which you find it hard, you can just mail me. Okay, so in the next video I'll be back with D'Alembert's ratio test. So till then, bye.